We know that weather and temperature has an effect on the range of EVs, but by how much? Over the last year, Consumer Reports conducted seasonal testing on some new all-wheel drive EVs that we have in our fleet. We had the same drivers drive in a Caravan on 3 different days. We tested on a frigid day in the winter, a mild day in the spring, and a hot day in the middle of the summer. Now, of course, each car started with a full charge. We let them charge overnight to their max capacity. We also checked the tire pressure to make sure it aligned with what the door sticker says it should be. All the cars were driven on the same 142-mile loop for each test. We saw a clear trend among all the vehicles we tested. Unsurprisingly, winter resulted in the shortest range. What was most surprising, on the other hand, is that we expected to get the best range in mild temperatures because the air conditioning and heating system would have to do less work. But in fact, we got the best range on the hottest day during the summer. What this test helps show is that EV range is not an absolute metric. Weather, hills, climate temperature, cargo, passenger, aerodynamics, not to mention speed and traffic, can all have dramatic impacts on your EV's range. We also need to adjust our mindset a little bit for EVs. Unlike a gas car where they're more efficient on the highway and less efficient in stop-and-go city traffic, EVs are the opposite. They're actually less efficient on the highway, as our test shows, and they're more efficient in the city. There are a couple reasons for this. First, an internal combustion engine has a sweet spot where it's most efficient. On the highway, where RPM is low but load is high, the internal combustion engine operates in a more efficient range. Next, internal combustion engines use fuel while idling and are far less efficient during stop-and-go traffic compared to an EV. Lastly, EVs get to take advantage of regenerative braking. This means that during stop and go in the city, some of that brake energy, rather than being lost to heat, is being returned to the battery. When you're cruising on the highway with your EV, this advantage is lost. Another interesting finding is that the Mustang Mach-E was the best at predicting its range. When we got into the car for all 3 tests, whether it was winter, mild temperatures, or summer, it did the best job at showing us on the gauge cluster how far it thought we could go.